Hi everybody, I've got a really quick one for you today. This is what I've been working on recently. This is a capacitive discharge spot welder. So mostly it's just a capacitor bank. Got two capacitor banks in series here. These are each 330 volt rated, 16 times 150 microfarads. And then this is a big thyristor, kind of like an SCR. And then over on this side, I've got a little trigger circuit for the thyristor hooked up to a 9-volt battery with a little micro switch with a chicken stick attached to it. And then this is the output transformer. Spot welding isn't too happy running at 600 volts, and I only had access to high voltage capacitors, so that's the core from a microwave oven transformer. I hacked away the 2 kV secondary and put in 2 turns of 2-gauge wire and put 2 big copper lugs on the end, and these can just push on a piece of metal down here. And then here's the charge circuit. I haven't really finalized this thing yet, but it works well enough for now. This is a flyback topology built out of e-waste. Heatsink with a MOSFET. This is a IRF 734 400 volt MOSFET. There's a gate driver that's not e-waste. Little current sense resistor. Hold up caps from e-waste. This transformer is from some e-waste. I don't remember what it came from now, but the turn ratio is 1 to 4.5, so 4.5 on the secondary. I've got a little snubber on the primary, and then the secondary just has this big, I think that's a microwave oven rectifier diode, and a 50 ohm charge resistor. Okay, so this is showing the voltage on the capacitor bank. The top trace is the current through the primary coil, and the bottom trace is the current through the secondary coil. You should see a classic flyback waveform as I power it up. We up the duty cycle. So primary charges up, builds a magnetic field, nothing happens in the secondary until the primary... Fuck. You may have heard that you can't just put diodes in parallel to handle more current. And that's true. Minor process variations between each single diode will cause a slight difference in the forward voltage, and whichever one just happens to have the lowest forward voltage is going to hog all the current and blow up first. And they'll blow up one by one in that order. You can get around this by putting ballast resistors on each one. That way the overall resistance of each branch of the circuit is nearly the same. Each of these 1N 4007s can handle the 30 amp pulse. 30 amps is roughly what I expect in the freewheel backwash from the output transformer. I think 4 of them should handle it. I think I lost one in the video you just saw because the 1 ohm resistors were quarter watt types, which cannot handle 30 amps or a quarter of that, or any fraction of 30 amps. So I've got 1 watt 3 ohm resistors here. I think they'll function a little bit better. I couldn't find anything bigger on hand right now. Okay, these 1 watt resistors were working perfectly, so I decided to sub in one of the old 1/4 watt resistors to give you some fireworks.